Chapter 4, Lesson 1 is on writing and graphing inequalities. Now, an inequality, all right, is these four different symbols, okay? Inequalities can be greater than, less than, greater than or equal to, less than or equal to. I guess another inequality up here would be not equal to, okay? The reason I have these open or closed circles underneath the greater than and less than symbols is that's going to be the circles we use when we are asked to graph an inequality, okay? So if we're given just a greater than or less than inequality, we're going to use an open circle. When we're given a greater than or equal to, less than or equal to, we're going to be using a closed in circle, okay? And I'll kind of explain that here as I go through these examples. All right, so my first example, okay, the directions would be to write this inequality, or sorry, to graph this inequality on a number line. So I already drew my number line. I have 0 in the middle, okay? Now, the only thing I really want you to do is you're always going to need to draw your number line with a 0 in the middle. And then when you graph the inequality, you're going to just write the integer or any number they give you on the number line, okay? So here it says x is less than -3. So I know I need to put -3 there, and negatives are on the left side of 0. And because it just had this less than inequality, I'm going to use an open circle above -3. All right, so we're really trying to graph all the numbers that I could plug in for x that are less than -3. Okay, which numbers on this side of the number line are smaller than -3, to the left or to the right, okay? All the numbers that are less than -3 are on the left side of -3. Those are all the numbers that are less than -3. So this is what the graph is saying. If I plugged any number in for x, okay, it has to be less than -3. So that means any number on this side of the number line would make that inequality true. If I plugged any number in that's on this side of -3, all right, it would make this inequality true. Say, because -5 would be over here, right? -5 is less than -3, so that would make it true. Now, if I thought about putting 0 in for x, is 0 less than 3? No, that's why my arrow is going to the left. I'm saying all these numbers on this side of -3 would work if I plugged it in for x. And the reason we're not filling this in is I have to leave kind of like a hole there because I cannot include -3, okay? We cannot include -3 in this solution because -3 is not less than -3, it is equal to. If I were to fill that in, we would say we would include -3, okay? All right, next example. X is greater than or equal to 5. All right, so I have my number line, right? We have to graph this inequality, so I make my number line, have 0, and then I'm going to put 5. Now, greater than or equal to, what kind of circle does greater than or equal to have? It is a closed circle. That means we are including 5, all right, in this inequality, okay? So it's saying x is my variable. So any number I plug in for x needs to be more than or equal to 5. What numbers are more than or equal to 5? Are they on this side or are they on that side? Numbers more than 5 are on this side of the number line. And we are including 5 because if I did plug 5 in for x, 5 is greater than or equal to 5, right? It fills one of those questions. It is equal to 5. So we're going to fill it in and include 5. So 5 would work, or any number on this side of 5 would also work if I plugged it in for x. That would make this inequality true. Okay? Now, let's go the reverse way. Maybe they give us the graph and they're saying to write the inequality. So an inequality needs to have a variable, your inequality symbol, and then your integer or any number. Okay? The variable doesn't matter. I like to use x. I like to stay consistent. So I'm going to write x, right? Because these are my next two examples, and they're going to give us the graph, and our job is to write the inequality. So x. Now we need to come up with one of these 4 inequalities, okay? Numbers that are going to the right are greater. So we know this is a greater than symbol, and it's an open circle. So which one of those is greater than? Right here, okay? So greater than, and it's an open circle, so I'm not going to put the or equal to line. And then the number that is, the circle is right above the -7, so it's saying that our variable needs to be more than -7. That's what this graph means. So I wrote the inequality for that graph. So x is greater than -7. Okay, now we're going to make the inequality for this graph. So I have my variable. Now we got to look at our circle and our arrow. So our arrow is going to the left. Numbers that go to the left Okay, all these numbers are less than. So it's got to be a less than inequality, and since it's a filled in circle, it's going to be the less than or equal to. So x is less than or equal to, and then just the circle that the number is above is 6. So x is less than or equal to 6. All right? All right, now, what if they give us a word sentence and then we need to write the inequality? We're not solving today, we're just writing the inequality, okay? So a number x, okay, is at most, okay? So it's not an equal sign today, it's is at most. So the most that x could be is what we need to ask ourselves. What's the most that x could be? It is negative 10, okay? So x cannot be more than negative 10 because the most it could be is negative 10, all right? I know I have negative 10 over here, so now I just need to figure out what my inequality is. So we said the most it could be is negative 10. It could be negative 10, so it could be equal to, right? But it cannot be more than, right? So it's going to be x is less than or equal to negative 10. That's what at most means, less than or it could be equal to, right? The most that it could be was negative 10, but it couldn't be more than that. So x is less than or equal to negative 10. All right, twice a number y. So twice a number y means you're taking 2 times y. Is more than, that's pretty straightforward, is more than. Okay, you're just gonna give me the greater than or more than symbol, and then negative 2/5, or sorry, negative 5 halves, all right? So we're just writing the inequality today, you're not having to solve, okay? So twice a number y is more than negative 5 halves, 2y is greater than 5 halves, okay? Last kind of example. So it's going to ask you if a certain integer is a solution to the inequality. So what you're going to have to do is you're going to have to substitute what they ask you to see if it's a solution into the variable. So they're saying, is negative 2 a solution of the inequality? Well, this is the problem they give you. Y minus 5 is greater than or equal to negative 6. So what I need to do is I need to substitute negative 2 in for y. So we're trying to figure out is if I plug negative 2 in for y, does it make this inequality true? That's the idea here. So negative 2 minus 5 is greater than or equal to negative 6. So negative 2 minus 5. Okay, my signs in front of the 2 and the 5 are the same, so we add. 2 plus 5 is 7. 5 is farther from 0. Negative. So we have to ask, is negative 7 greater than or equal to negative 6? Well, we know it's not equal to, so is it greater than? Is negative 7 more than negative 6? And the answer is no, because negative 6 is closer to 0. And remember, when we compare two negatives, the smaller looking negative is actually bigger because it's closer to 0. So negative 7 is not greater than or equal to negative 6, so we would say no, okay? We need to kind of have this line right here and then a yes or a no answer, because it's saying, is negative 2 a solution to the inequality? But when I plug negative 2 in, this did not make this inequality true, so we would say no, negative 2 would not work if I plugged it into y. Okay? Last one, is negative 5 a solution? X plus 12 is greater than 7, so I need to plug negative 5 in for x. Okay, now we need to kind of simplify this up. Negative 5 plus 12, well, our signs are different, so we subtract. 12 minus 5 is 7. Is 7 greater than 7? The answer is no, 7 is equal to 7. So 7 is not greater than 7, so we would say no, negative 5 is not a solution to that inequality. Okay? All right, homework is on page 128. You will do 5 through 21 odds.